This is example 5 of the matrix algebra lab. We want to use the inverse matrix to solve the system of linear equations. The system of linear equations is 4x plus y minus 2z is equal to 2, 5x minus 3y plus 2z is equal to 5, and x minus 5y plus 5z is equal to 5. So the first thing we need to do is write this in the form of a matrix A times a matrix X is equal to a matrix B. And to do that, we're going to take the coefficients of our x's, our coefficients of our y's, and the coefficients of our z's into our A matrix. And then our X matrix is all our variables in a row, our x, y, and z. And our B matrix will be what all of these are equal to. So, writing that out, our AX is equal to B. So, the coefficients for our x's is 4, 5, and 1. Remember, this is kind of like the x column here. For the y column, we have a 1, negative 3, and negative 5. And for our z column, we have a negative 2, 2, and 5. And for this to actually make sense in terms of matrix algebra, we have our, so this is our A matrix. We need to have our X matrix here, which is going to hold all our variables. So it has our X, our Y, and our Z. When you do matrix algebra, you take the first row here and multiply it by the columns. So you would see if you multiplied these two matrices, you'd have 4x plus 1y minus 2z, which is equal to exactly what we have here in the first row in the first equation. So now we have to have our B matrix. This is our X matrix. This is a different X than this X. So we have our B matrix, which is everything that this is equal to, 2, 5, 5, 2, 5, and 5. And so we have A times X is equal to B. And in this equation, we actually want to solve for what our variables are, which is our X matrices. So we want to solve for X matrices, but we can't simply just divide by our A on both sides because that doesn't make sense in matrix algebra to divide by A. Instead, we have to do a inverse of A. So for us to get A on this side and get this matrix X alone, we need to take the inverse of A on both sides. So our matrix X, this is our big X, our matrix X, I'll write it like that, is equal to the inverse of our matrix A times our matrix B. So that's how we're going to solve for our matrix here, our X, Y, and Z, which is what we want. And we're going to do that by a calculator. So turn it on. We're going to go into our matrix menu, which is second x to the negative 1. We're going to edit. We're going to go into A and put in everything that's in this matrix into here. When you do that, you're going to also go back into our matrix menu, go back to edit, and edit B, and put in everything that's in our B matrix here, 2, 5, 5. When you're done, press second mode to quit. So we need to enter A to the negative 1 is B. So we have our A. We're going to get our A, second x to the negative 1, and our A. We're going to do this x to the negative 1 to get the inverse of A. We're going to go back into our matrix menu, second x to the negative 1, go down to B, press enter, and then press enter again. You see that we have negative 5, negative 26, negative 24. So what that means is that our big X, which was equal to A to the negative 1B, is, and our A to the negative 1B is negative 5, negative 26, and negative 24. And if you remember, our matrix X was held all of our variables, X, Y, and Z. So So this is our X matrix, and this is our A negative 1B matrix. And all this simply means is that X is equal to negative 5, Y is equal to negative 26, and Z is equal to negative 24. So we can also write it as an ordered pair. So we have negative 5, negative 26, and negative 24 as our answer to the linear system that we had at the very beginning.